Welcome to the Pachehra Talks, and today we are going to explore encryption. We will try to understand this first, just for the newbies, for the freshers who are there for Azure security, and then we'll start digging the encryption from the Azure services perspective and all the things that Azure offer and provide to encrypt at rest, in transit, or in use while using the Azure services. So, just for the beginning purpose, for the beginner's purpose, what is encryption? Well, in a simple terms, if I'm writing Azure and it looks like something this, do not try to decode it. This is just an example, a random one. If I write cloud and it seems like this, right? So this is what the encryption means, a method of converting data into coded format. So this is the coded format. This format, which doesn't make any sense, is the coded format, and this is your data. So this is called ciphertext, the coded format, which cannot be easily understood by unauthorized people. So what is happening at the back end? Okay, this is just an example. Do not try to find out how it is. Try to understand the logic and the concept behind it. So it uses algorithms. It uses algorithms and cryptographic keys to transform readable data into a format that can only be read by if decrypted. So this process happening through algorithms or cryptographic keys. Okay, cry keys, cryptographic keys, and these are not algorithms. Okay, so these two things help doing what? Converting plain text into what? Any guesses? Ciphertext. Okay, ciphertext, which can only be read if you have the keys to decrypt it, if you have the authority to decrypt it. Remember, I use the word unauthorized people, which cannot be understood by unauthorized people. So this is what, in simple terms, the encryption is. So what exactly encryption is helping us doing? Any guesses? Anything that comes in your mind? Well, if there is something that you cannot see, only authorized people can see, unauthorized people cannot see, what it is confidentiality, right? You must have seen confidential files. This is confidential, so you're not authorized for it. So it helps, encryption helps protect the confidentiality of the data, along with what? Well, if the authorized people only see and they cannot make any change, so that means integrity. It will also help you maintain the integrity of the data. Now this is what it helps achieving encryption. If you remember, at the beginning of this security specialist series, we talked about the basic goals that this security needs to achieve is CIA: confidentiality, integrity, and availability. So this helps us in achieving confidentiality and integrity. So let's see what are the different types of encryption. This is again just for the basic fundamental stuff. Then we'll start digging the Azure so that everybody is on the same page. So there are three types of encryption, as you can see on the screen. What are those three types? Well, these are symmetric encryption, asymmetric encryption, and hashing. To be uh, clear, these two things are the encryption. Hashing is not exactly encryption, but it is good to know, right? So symmetric and asymmetric, two types. Hashing is something that's a good to know information. It's not exactly the encryption, but kind of. So let's try to understand the symmetric. So what is symmetric encryption? Well, You remember I talked about keys. So to encrypt this data, to become this encrypted something something XYZ, which cannot be read by the unauthorized people, there is some kind of mechanism like keys are involved. In a very simple terms, you can understand if we can use numbers instead of letters. So your numbers would be the key. For A, we could say 1. For Z, we could say 25, 26. You can count A, B, C, D, E, F like this. So that would be your key for this silly example, but just to make us sense out of it, to understand the concept. So for symmetric encryption, we uses the same key for encryption and decryption. For example, if you want to decrypt it, you could apply the same number logic, it will decrypt it. But do not apply here, these are the random. Okay. For example, if you write 1, that means A. If you write A, that means 1. The numerical numbers would be the keys. For symmetric encryption, same key used for both encryption and decryption. That's what the symmetric means, same keys. Same keys for encryption and decryption. Simple. There is nothing complicated. Very simple. Okay. And it is suitable because we should know where we should use these kind of things for large volumes of data where we need to encrypt, especially at the rest. So making it suitable for encrypting large volumes of data. That's not a hard and fast rule though, but if you do not have to maintain any compliance, you're not maintaining any highly sensitive data, and you need to encrypt it, you can simply utilize symmetric encryption for the large volume of data. Okay. All right. So let's take an example for this so that we can understand this is symmetric when we talk about Azure services, which is AES, which is Advanced Encryption Standard, AES, Advanced Encryption Standard, which is a widely used symmetric encryption algorithm often utilized for encrypting data at rest, such as files on a disk. What is files on the disk? Azure disk on Azure VM. Right, Azure storage account. So you can easily relate, oh, that's going to encrypt through AES, Advanced Encryption Standard, when we talk about encryption data at rest. All right, good. So symmetric encryption, sorry, asymmetric encryption. Now, as per the name, it reveals itself. It's asymmetric, means the keys to encrypt and keys to decrypt are not the same. You can also call it a public key cryptography. Public key cryptography. Okay. Two keys, one for encrypt, one for decrypt. As the name says, asymmetric. Okay. And now you can understand when I'm saying public key, there must be a private key, right? So these keys are used for encrypting and decrypting data, ensuring secure communication between the parties. The public key can be shared with anyone while the private key is kept secret, right? So we can talk about a little more so that we can understand the logic behind asymmetric encryption. Well, the process generation of the key starts generating a pair of keys. Anyone can use the public key to encrypt data, and it is publicly available usually, but only the holder of the corresponding private key can decrypt it. So we are generating two keys, one so that other party can use that public key and encrypt the data and send the data to us, because we owns the private key, so we can utilize that private key to decrypt the data. So it is more secure. So when someone wants to send secure data to the key owner, they encrypt the data using the recipient's public key. Since the key is public, that's the name, public, it can be easily shared without any security risk. Okay, so that is the logic behind it. What about the security piece? The strength of asymmetric encryption lies in the difficulty of delivering the private key from the public key. Yes. With current technology and algorithms like RSA, Doing so within a reasonable amount of time is practically impossible without knowing the private key. So it is more secure as compared to the symmetric. And yes, of course, it will take a little more time because there are two keys involved, two kind of deciphering things, right? So that's the reason large volume of data, if you understand the logic, it takes a little more time than this. Not that much, but yeah, a little bit. Then finally, hashing, as the name says, it will hash the data. Okay, it's then eventually that the data is encrypted because it became hash, right? So technically, it's not encryption, but it will transform data into a fixed size hash that cannot be reversed. It's used to verify data integrity and authenticity, because if data become hash, it will become the same kind of hash and it will never reverse, so you can easily verify the integrity and authenticity. The example is SHA, which is secure hash algorithm, 256 bit, that you might have seen written so many places, especially Azure documentation or any security piece that you're reading. So SHA 256 is used for verifying the integrity of data, such as checking the authenticity of downloaded files, right? Now let's quickly, this is the very basic things that we would like to know before we jump to the Azure. And I think we did a pretty good job. Oh, you guys should tell me. I'm just trying. I don't know yet. Your comments will help me understand. I'm I'm getting comments regarding the voice is low. I'm trying to make it little better. Let me know if it works. All right, so encryption in Azure, there are like three kind of encryption. Well, when you're using a data, which or when you're just your data is there, you're not using it, it is there resting, and when it is traveling. So data at rest means encryption of data when data is at resting. So encryption at rest, encryption in transit, when data is moving it should be encrypted, and while the application is using the data. Okay, so how can we make sure that data is encrypted or secure while when it is in use? All right, so let's start one by one. Encryption at rest. So as I said, it protects your data from unauthorized access when it is stored. You can keep making our notes: stored or resting. Very simple example is what? Just think about the previous notes. AES, yes, that is correct. AES is the example. Azure Storage uses AES 256 encryption to protect blob, file table, queue data. For databases, Azure SQL database employs TDE. Yes, that is also a at rest TDE, transparent data encryption. And AES was advanced encryption standard. So TDE also automatically encrypt database files. These are the facilities or features provided by default by Azure. Okay, so this encryption at rest is critical for protecting stored data from threats such as unauthorized access, unauthorized access. What will it maintain if we are blocking the unauthorized access, protecting the data from unauthorized access by encrypting it at rest? It will help in achieving confidentiality and integrity. So it's a fundamental aspect of data security, especially for sensitive information stored in the cloud. Right? So security, security, security. That's what we are talking about in security specialist series. Okay, so encryption in transit. Now the data start moving. Okay, the data start moving. So we need to make sure it is encrypted while it's moving. So securing data as it moves between systems or networks. Uh, moving between systems or network, so that we are in line, and this will help you uh, revise or just summarize at the end. All right, so data moving between Azure data center is also encrypted. Do not think like they are just leaving it like that. Okay, so how the data is encrypted when data is moving between the data centers? is through TLS, which is Transport Layer Security. It seems familiar. If not, just be with me, it will be. Well, Azure VPN Gateway and Express Route also encrypt data in transit, ensuring secure connections between on-premises network and Azure or between the regions. Okay, VPN Gateway, it has that feature, we already talked about it, that encrypt the data. But if you're wondering, I mentioned Express Route. Well, there is a way that you can do it. It's not by default. Anyways, so how it is important? Well, it is essential for safeguarding data as it moves across networks, particularly over the internet. It protects data from interception and tampering, ensuring the that sensitive information remains secure during the transmission. So that's how we can achieve it in Azure. Well, do not worry, we're going to go deep into these things. We're just getting familiar with all these three types of encryption. So in use, while data is in use means processing. Okay, so ensuring the data is protected while being processed. Azure Confidential Computing offers secure enclaves for processing sensitive data with a protected CPU environment, preventing unauthorized access for or disclosure even when data is in use. And protects data from threats that target the processing stages, such as malicious insiders or vulnerabilities within the processing environment. It's important for scenarios where data privacy and integrity must be maintained during the computation. You gotta maintain some kind of compliance where you need to maintain end-to-end encryption. All right, so we got familiarized ourselves with these three kind of encryption: at rest, in transit, and in use. We talked a little bit. Now it's time to explore them, dig them further. So, encryption. Uh, at rest. Let's explore the rest first. Encryption of data at rest in Azure is a critical security feature designed to protect data stored on Azure services by encrypting it while it's not being accessed or processed, because it is stored. That's why it's rest. This means the data is encrypted on the disk and storage layers, making it unreadable or to unauthorized users or entities without the proper decryption keys. So this is what we have learned as of now. Now it's time to dig Azure services and their implementations. So for example, we talked about AES, Azure Storage Services, blob, file, and queue tables. So Azure Storage automatically encrypts data before persisting it and decrypts the data before retrieval. So using SSE, yes, SSE, storage service encryption with managed key, means the keys which is used to encrypt the data is managed by the Microsoft. You can also use your own. So you can have your own keys as well, that you don't want to share your keys to anyone, including Microsoft, because you got to maintain some kind of compliance or regulatory uh, stuff. Then of course you can utilize your customer managed keys as well. And the question for all of you, if you're listening properly, where do we store the keys in Azure? All right, just think about it and answer me. This is the storage that we talked about. What about, let's take the another example of, let me write it down, Azure storage. This is the Azure storage. Now, let's take an example of Azure SQL. Azure SQL database, what it does, it TDE, if you remember, we talked about above, transparent data encryption, which is available to protect SQL database files. TDE automatically encrypts the database, associated backups, and transaction log files at rest without requiring changes to the application. All right, what about Azure VMs? Well, for VM disk, Azure offers ADE, which is Azure Disk Encryption. Okay, which leverages what? If it is depend on OS. If it is Windows, then BitLocker, and if it is Linux, then it is, any guesses? If you're saying DM crypt, then it is right. All right. So what about Cosmos DB? I'm just taking a few examples from Azure. Azure Cosmos DB. Well, it provides encryption at rest with no configuration at all. No configuration, no additional configuration is needed. By default, you get the data encrypted at rest automatically. And again, you can utilize your keys and customer managed keys. You can use both. All right. So, how to use this encryption at rest? Well, if you talk about Azure, it's enabled by default, as we keep on highlighting this. Many Azure services like Azure Storage and Azure SQL Database enable encryption at rest by default using Microsoft managed keys. There is no additional actions required to benefit from this level of security. You could also utilize customer managed keys. So, this is all about Azure encryption data at rest. We took a few examples. We tried to explore and understand this. Now it's time for in transit. Oh, we have already mentioned the benefit confidentiality, integrity, or managing the compliance, right? So it's time to explore the encryption in transit, which is a fundamental security measure that ensures data being transmitted is safe, secure, and encrypted, making it unreadable to unauthorized parties. Azure provides built in support for encryption in transit across various services. Implementing it typically involves enabling HTTPS for web services or utilizing secure connection strings and protocols for other types of data transfer. Here's how to use encryption in transit in Azure, along with the few examples as we're going to talk about. So, for web apps, enable HTTPS to ensure web traffic is encrypted. You can enforce HTTPS by setting the HTTPS only feature to on in app service settings. Custom domain can be secured by uploading your SSL, TLS certificates or purchasing them through Azure. You do have an option for the app services. So it protects web traffic against eavesdropping and tampering. HTTPS, SSL, TLS is the way to get it, and it helps in uh, eavesdropping and tampering, maintaining so that they cannot do that. Okay. Now let's take an example of Azure SQL. Azure SQL database encrypts data in transit by default using TLS. Okay. And ensure your client applications are configured to use encrypted connections when communicating with the Azure SQL database. So you need to do a little work on your application if it is not like that already. So it secures database queries and data transfers between your application and the database. Okay, because it's transit. Let's talk about Azure Storage. Data moving to and from Azure Storage is encrypted in transit by default again when using HTTPS endpoints. Always use the HTTPS protocol when accessing blob, queue, table of file storage. You can also check that box in the properties of Azure Storage so that it will enable HTTPS. Then if we talk about virtual network, for cross-premises connections, use Azure VPN Gateway or Azure Express Route with encryption to secure data in transit between your on-prem network and Azure VNet. So that's how we can secure Azure VNet. We talk about AKS, we can use TLS to secure communication between your application component within AKS. This can involve setting up ingress controllers with TLS termination or implementing service mesh solutions that encrypt inter-pod communication. If we talk about API management, we can enforce HTTPS or APIs managed by Azure API management by setting up SSL, TLS certificates and configuring your API gateway to and only accept secure connections. Okay. Now, ultimately, it is all about HTTPS, SSL, and TLS. Even if you are using Azure Service Bus and Event Hub, connections to Azure Service Bus and Event Hub uses TLS encryption by default. Ensure client uses, if you talk about Service Bus, AMQPS protocol and HTTPS for Event Hubs to maintain the encryption in transit. So, in a nutshell, all the services that you utilize for your workloads in Azure provides you the features, a lot of them by default, to make sure your data is encrypted in transit and it is secure for unauthorized. It is secure and it is not okay for it will save you from the eavesdropping and tampering, and for unauthorized people, not allowed at all. So, if you have to conclude, always use HTTPS, monitor and upgrade the TLS versions, and use Azure managed services so that you get away a lot of things that you need to do to enable the encryption. Managed services has all those things by default, so your admin overhead will be saved. So, what is the security benefits we talk about? The two we have mentioned: eavesdropping and tampering, data protection, and of course, trust. This transit establishes secure channel for communication, fostering trust between clients and services by ensuring data integrity and confidentiality. All right, so it's time to dig a little further. The in use. Well, encryption in use refers to protecting data while it's being processed. So, ensuring that it remains encrypted not only at rest and in transit, but also during computation. This level of encryption is critical for safeguarding sensitive data against unauthorized access, including from operators of the computing platforms. Azure offers several services and features that support encryption in use, enhancing the security of data during the processing. Let's talk about those services which helps in use, or well, data is processing. Well, we gave the example at the beginning of confidential computing. So, yes, Azure offers confidential computing VMs which provide trusted execution environments, TEE. Trusted execution environments, also known as secure enclaves. These enclaves protect the confidentiality and integrity of your data while it's being processed, isolating it from the rest of the system. Then we have Azure SQL Database and Azure SQL Managed Instance. I should write here, otherwise it will look little blank, which is not right. Oh, not for VMs, which is trusted execution environment. Now for SQL or MI, enable always encrypted for both, which ensures sensitive data is encrypted within the client application and never revealed in plain text to the database system or the database administrator traders, not trade administrators, not trade administrators. Always encrypted. Okay. Now, if you are using AKS, you can implement code and data encryption within the application container themselves. For AKS, you can also use confidential computing nodes offered by Azure to run Azure Kubernetes cluster, which was TEE for VMs. Okay. And the question I asked, use Key Vault. While Key Vault is primarily used for managing encryption keys and secrets, it can also facilitate encryption in use by enabling applications to use keys stored in Key Vault for encrypting data during processing without exposing those keys. And if you talk about web apps, although Azure web apps don't offer a specific encryption in use feature, you can implement application level encryption for sensitive data being processed by the web application. This involves using encryption libraries and managing keys securely, potentially leveraging Azure Key Vault. All right, so we are through with all these three types of encryption that Azure provides. We talked about usually most often used services where we can implement these encryption, and what are the basic of these encryption and things like that. Now let's conclude this with the best practices for encryption in use on Azure first. So this is what we were completing. So let me put it here. So, identify which part of your data are sensitive and require encryption in use. Not all data may need such a high level of protection. So, you need to understand the data and use Key Vault as we talked about, and limit the decryption of sensitive data to the minimal scope necessary for processing, and ensure the data is not exposed in plain text unnecessarily. And when implementing encryption in use within your application, follow secure coding practices to avoid introducing vulnerabilities. So it will give the protection against unauthorized access, it will give you the data privacy, and of course manage the confidentiality and address the challenge of protecting data during computation, completing the data protection lifecycle, and ensuring comprehensive security for cloud hosted application. So finally, the implementation of various encryption methods in Azure at rest, in transit, and in use plays a pivotal role in enhancing the overall security posture of data and applications hosted on the cloud, specifically Azure we talked about. So uh, let's just summarize and talk about what all things we are getting and end the video. It's already been too late. So the combined implementation of encryption at rest, in transit, and in use in Azure provides a holistic approach of data security. Holistic approach for data security. Okay, which is one of the layers that we should focus upon, because everything is all the security is about securing your data. So ensure data confidentiality, integrity, and availability across storage, transmission, and processing stages. That's what the holistic means. Enable organizations to comply with the strict regulatory standards and protect sensitive and personal information effectively. So you should know your data and then encrypt it and protect it. Build trust among users and customers by demonstrating a commitment to safeguarding data against current and emerging cyber threats. So, by leveraging Azure encryption capabilities, organizations can significantly enhance their security posture, mitigate risk associated with data breaches and unauthorized accesses, and ensure that their data remains secure, private, and compliant with global standards and regulations. From the security specialist perspective of AZ500, all these things will help you understand how to secure your data layer and what are the means that you can do that in different Azure services. Well, thank you for watching. I hope it was informative and you enjoyed. Take care. Bye bye.